our workspace. If you can see my screen, you see the problem you just asked about, match each example to the property used.
Yeah.
Okay. The multiplicative identity is when you multiply by 1. And that's the only one that has that in it.
Okay.
Basically, you multiply by 1 and you get itself, whatever that is. The multiplicative inverse is what you use to get 1, to get 1. And the example that they would use is when you multiply by the reciprocal. So you actually see that in a few places here, but the best example of that, I suppose, is 5. I guess that is the right one there.
Okay.
The associative property has to do with parentheses and the placement of them. Like these aren't. I mean, I can see why these would be complicated to look at. The commutative, I guess it's somewhat related, has to do with the order in which they appear. So it's a different order, basically. So like when I look at number 3, I see a 4 and a 4 in the same position, and the -3 and the 1/4 and -3, they switch positions. So that's why it's a different order for that one.
Oh, okay.
And then the associative, you likely saw examples that weren't with fractions and negatives and stuff. With associative, you have the same order. That's probably important here. It's the same order, but the parentheses appear in different places. That's why 4, you have a 4, 1/4, -3, 4, 1/4, -3. It's in the same order, but the parentheses appear around the first 2 over here and the second 2 over here.
Okay.
And that's as much as I can explain on that. So if you got that down, let's go to the next one on this.
All right. Can we go over 12?
Pulling 12 up here, it says solve each equation for x, state any restrictions on the variables. Okay, so number 12 says solve each equation for x, state and any restrictions on the variables. So the only restrictions would occur is if you were dividing by a variable at some point. And there's no current division, but there could be. So x appears in 2 places here. And that means you're going to have to factor it out. It's x t minus u equals 3t. Is that okay? That
Yeah.
factoring it? Okay. And then you divide both sides by t minus u. So you get x equals 3t over t minus u.
Oh, okay.
So this is okay, except for where t cannot equal u. And that's maybe uncomfortable to write as a student because you're used to there being numbers there. But imagine if t equaled 2 and u equaled 2, well, the bottom would be 2 minus 2. That would be bad. So
Yeah.
that's the restriction they're looking for. You could say it in words. You could say t and u must be different. That'd probably be okay at this class. But you need something. That's what they're looking for. That's what the instructor was looking for on this one.
Okay. After that, maybe 16 would be good to go over.
16, yeah.
I know there's a formula, but I don't remember.
This is this is more of a draw. We're going to draw sort of a picture, and then there is an equation. It's distance is equal to rate times time. So two buses leave Dallas at the same time, but they go in opposite directions. So here's Dallas, and one's going that way, and one's going that way. Okay. One bus averages 58 miles per hour. So we're going to say 58 miles per hour that way, 52 miles per hour that way, and they want to know when they're 330 miles apart. Does this picture, is it something you made, or is it familiar to you?
Yeah.
Okay, so distance is equal to rate times time, but there's really two scenarios here. There's the bus on the right, and then there's the bus on the left. So the distance, we'll call this distance 1. Distance 1 is equal to 52 times t. So we don't know how far how long they've been driving. Distance 2 is 58 times t, because they leave at the same time. What does d1 plus d2 have to add up to? It's given in the problem. It's how far apart they are.
330.
330. So then you take these two expressions and substitute them in. You say 52t plus 58t equals 330. You get 110t equals 330. So t equals 3 hours. And that's all it's asking for.
Got it. Okay, after that, 21, I just don't remember what to do with the absolute value thing. It's like I don't remember.
Sure. Were you able to do 22? Because it's some ways more sophisticated than this one.
Okay, yeah, so we can do that.
It's up to you, totally up to you. So 2x, so when you have the absolute value of something equals a number, you set up whatever's in here, I'll call that in parentheses, equals the number, whatever's in there equals negative of the number. So in your problem, it's 2x plus 3 equals 5, comma, 2x plus 3 equals minus 5. And you solve both of these.
Oh, okay.
So the one on the left here is 2x equals 2, x equals 1. This one's 2x equals minus 8, so x equals minus 4.
Okay.
There's nothing different about 22 except you have a variable on both sides, and you have to check for the solutions being correct. Here they're both correct. You can both plug these numbers back into the original, and they both work. But I think in 22 you get a situation where they don't work. I'm not sure though. We can do it if you'd like.
I can check the answer. It just says x is -6 or -2, so I don't think there's extraneous solution.
So they both work. That's
yeah.
right.
Okay, and then just 23 is the last one.
23, okay. All right, the temperature of a refrigerator is at least 35 degrees and at most 41 degrees. So it says write a compound inequality. So the temperature T is between these two values. That's the compound inequality part. Compound means you have both of these symbols in there. The absolute value is a little bit more difficult. It's the absolute value of, and then you have your variable minus the center is less than or equal to the width divided by 2. And this looks really complicated until we put some numbers in here. The center between 35 and 41 is the average. You can even put the average there. What's the average between those numbers? Well, it's 38.
Okay.
So it's t minus 38. Now the width in this case is 41 minus 35, which is 6. Divided by 2 is 3.
Oh.
and then you're done. I mean, you have to know this. Your instructor would have shown you this. They give you. There are probably other examples like, you know, if a package weighs between this and this, it's the same rate. You know, write in an inequality for that.
Okay. All right. We can move on to the next.
Okay, I've got chapter 2 practice test open. What should we look at first?
Maybe number 4, number 5.
Okay. Okay, number 4, it's f of -2 plus g of -9. The function f is given up here, the function g is given up here. So it's two separate problems. You have to find f of -2, which is 3 times -2 minus 4. I'm just getting that from here. You get -6 minus 4 minus 10. And then you can find g of -9. That's the absolute value of -9 plus 3. So that equals 9 plus 3, which is 12. So just take those two values, 10 plus 12, and you get 22 for those.
Oh.
Okay. Let's see. 5 is similar. You have to find you have to find f of 8 and g of 1, two numbers, then you divide the result.
Okay.
I can go through that if you'd like, but I think it's probably
it's just
probably clear what to do. It's the same thing. Yes.
Okay, and then number 6. I don't remember what constant of variation means.
Sure. It's going to be much clearer after I explain it. Let me just get this snipped in. Direct variation is the equation of a line that goes through the origin. And you might think, well, maybe that doesn't sound any more complicated. Well, they write it this way. It's y equals kx, and that's for direct variation. So you're used to seeing like y equals mx plus b. It's the same thing here, except b, if b equals 0, it becomes that, and they use k instead of m.
Okay.
So these problems are always set up the same. They have some given information, and you use that to write the equation. So it's -24 equals k times 6. So I just took these values and put them into this equation over here. You solve for k. So in this case, k equals -4. You're dividing both sides by 6.
Okay.
Then you rewrite the equation. So you have y equals -4x. And then they always give you a value. Like they give you a value in this case when x equals 5. You see up here, find the value of y when x equals 5. Well, you put 5 in. You say, well, if x equals 5, this is y equals -4 times 5. That's -20.
Okay. Yeah, that makes sense. All right, after that, it's just slope stuff, graphing, transformations. Maybe we can do 18.
Okay, let me get caught up to you here. You want to do 18, you said?
Yeah.
Sorry, just scrolling here. Okay. Yeah. So you're allowed to use Desmos, right?
Yeah.
Okay. I mean, I don't mean to shortcut the learning, but that's what I'm going to do here. So let me just do a new share, and I will just show you how to graph this. I mean, it's really no different than that. Absolute value, ABS, x -1, -2. If you don't know where to find the absolute value, you can come down here to the keyboard, and they have functions, or you can see the absolute value of A down here. The only points that your instructor really cares about is the vertex, and then any intercepts And I'm just going to snip this into your graph, into the workspace. You'll see that you have to make a dashed line, but kind of does all the work.
Yeah.
Is that there's this. So I'm not sure what else to say. I mean, we could obviously, I could show you how to do this by hand, but that doesn't seem to be needed. So
Yeah.
I would just get comfortable. Oh, it should be -2. I gave you the wrong graph. It does change these values slightly. So let me re-snip that in for you. I did that the other day as well. Made a huge difference in that problem. Had one number off. Okay, so what is the next question to look at?
21.
21 here. Okay. Ooh, lots of these. All right, we'll do part A by hand, and then part B, I'll show you how to use Desmos for if you don't know how. It's worth looking at. So evaluate f of 2. So you go over here. This first one is good when x is greater than or equal to 1. This second line is good when x is less than 1. So is 2 greater than or equal to 1? The answer is yes. So use that top one. Use 2 times 2 minus 3, which is 4 minus 3, which equals 1. F of -3. Is -3 greater than or equal to 1? No. Is -3 less than 1? Yes. So use that one. It's -3 plus 1, which equals 3 plus 1, which equals 4. Then at 1, is 1 greater than or equal to 1? The answer is yes. So it's the top one there. 2 times 1 minus 3 is -1.
Okay. Graph it.
So the graphing here, let me go back to the Desmos screen. Sorry, to get new share. Where'd happened to it? Sorry, get where things aren't the way I want. Sorry. Okay, there it is. Okay, share that. So you type the thing you're trying to graph, 2x minus 3, and then you use the curly brace. Have you seen that before?
I think so.
And then you type in the inequality x greater than or equal to 1. So the key thing is, remember, is the curly brace. I don't have a Mac, but for me, it's above the bracket.
Yeah, me too.
And then you graph the other one, minus x plus 1, curly brace. That's what you put your domain in, x less than 1. And you can say less than or equal to. And if you can't find them, they're down here again. So this is the picture that your instructor is looking for. You definitely want to label those points if you can. That will help with your grade. I'm going to snip that in to the workspace so that you've got it, and then I guess we can continue. That's it. I mean, there's nothing else to do on these. These are not meant to be difficult when you can use the calculator that your instructor is allowing you to use. So you said 21. We got that all down.
Yeah.
Anything else on this exam?
No, I know how to do 22, so we can move on to
Chapter 3 practice test.
All right. Can we go over the 1 through 3? I don't know if I remember the consistent dependent ones.
Okay. These are definitions. You're more likely to get a question that gives you a system, and then to have to decide what it is. So if it has no solution, it's considered inconsistent. Okay. If it has a solution, then it's considered consistent. Infinite number of solutions is called dependent. So if it has one solution, it's called independent.
Got it.
the system is we have to solve this. So because that'll help us figure out these words here. So let's solve it by adding 2x equals 6, x equals 3. When you plug 3 back in, you find that y is equal to 2. So since it has a solution, this is what it means by a solution, an ordered pair. Ordered pair. Since it has a solution, it is consistent. Since it has one solution, it is considered independent.
Okay.
Now, it might be reasonable to ask, well, can I get an example of something that's inconsistent? Well, that means it has no solution. That's an example of two lines being parallel. And then you might want an example of something that's dependent. That's when they are one line on top of each other. And you may be wondering how that happens, but again, I can provide examples if you want, but that's what's happening here.
Yeah, I remember that.
Okay, great. Where should we go from here?
Number 9.
Number 9. Okay, graph. I kind of remember doing something like this with you. First thing I'm going to do here is I'm going to again go to Desmos, and then I'll let me share that screen, and then we'll talk about how to do this. So we'll do a new share. Why can't I find what I want? Oh, that's why. All right. So the first thing it asks you to graph is it says 1 less than or equal to x less than or equal to 6. So that's a vertical column space there. And then same thing with y. 2 less than or equal to y less than or equal to 5. So now you're in this rectangle here. And then this rectangle is cut by the line x plus y less than or equal to 10. So what you're looking for is something that is overlapped by all three.
Oh, I remember this.
Okay, so the corners here are the possibilities, but not this one up here in the top right. So let me snip this in, and I'm going to snip it in down below. So when it asks for the vertices, it's asking for those 5 points that I've labeled there. And I'm going to write them down, and then we'll talk about how to do the next part. So the vertices are 1, 5, 1, 2. I should have put that one first. 5, 5, 6, 2, and 6, 4. Okay, now let me share the other screen again, and we'll talk about how to find the maximum or the minimum. It could really be either, depending on what the question asked for. To do this, you just make a table here. You have your x comma y, and then you find your p equals 3x plus 2y. So when you put in like the point 1, 2, p is equal to 3 times 1 plus 2 times 2, which is 7.
Okay.
And you do this for all of them. So like 1, 5, you do the same thing. P equals 3 times 1 plus 2 times 5 equals 13, and so on. So what I'd like you to do, can you do the last 3 for me? I'm just going to step away briefly. I had to grab some water, and let me know which one is the biggest value of those. I'll be right back in 60 seconds. Hey Ella, how's that going?
Okay, I just finished. I got 6, 4 is the maximum at
Okay, I agree. So you got like 26? Looks like 26. Can you hear me?
yeah.
Okay. Uh, so I guess there's nothing else to comment on that.
Yeah. Okay.
That's number
So
9. Okay, so what's next?
so number 10, I think we just do that in the calculator, so I know how to do that.
You're not solving it though. You're just writing the matrix.
So I mean that's you just write 2, 4, -3.
Yeah, the last one has a little wrinkle to it because there's no z. So you put 0 in that position.
Oh, okay. Can we do number 11
Yeah. Let's get number 11 snipped in here. When is your final?
tomorrow?
Tomorrow. Okay. Do you know the format of it? Is it multiple choice? Is it like these short, like fill?
It's just like this, but he said it was about 7 pages.
Oh, lovely.
So,
Yeah. Um, so the goal here is to turn 3 equations with 3 variables into 2 equations with 2 variables. You almost never use substitution. Um, it does work, but elimination is kind of your big friend here. And you really just need to decide which variable you want to eliminate. It really doesn't matter, but I'm going to choose to eliminate z because that's just the most normal, I guess, thing to do in these problems. So like the second equation has minus 3z. Do you see that?
yeah.
So if I multiply the first equation by 3, I get 3x plus 3y plus 3z equals 27. And when I put the other equation below it and I add, I get 5x plus 6y equals 28. Okay, no z.
Mm-hmm.
And I need to do the same thing. So down here in the third equation, it's 2z. It's 2z. So I'm going to multiply the first equation by minus 2 because I really want to have the opposite sign with the number in front. I mean, that's what elimination is. So we get minus 2x minus 2y minus 2z equals negative 18. Again, I'm writing that equation under 3x minus 2y plus 2z equals 8. I'm adding them up. I get x minus 4y equals negative 10. So have I reduced this to 2 equations with 2 variables? Yes. And they have to be the same variables. Like it doesn't do you any good to get it to x and y and then y and z or any other variation on that.
Yeah.
So now the solving of this, it's really the same as the previous. I'm going to write the system together. 5x plus 6y equals 28. X minus 4y equals negative 10. So I have a choice here. I can eliminate x or I can eliminate y. I'm going to choose to eliminate x because I only have to multiply one of the equations. If I eliminate y, you have to multiply both equations by a number.
Mm-hmm.
So you get minus 5x plus 20y equals 50. I'm just going to bring this equation down. 5x plus 6y equals 28. When you add them up, you get 26y equals 78. So this is the important step here. You should get a nice number, and you do. If you don't get a nice number, you probably have made a mistake. You made a sign error, you didn't multiply everything, you kind of have to restart.
Okay.
Since you probably have access to some online resources during the exam, you may want to find a calculator that solves it so that you know what you're looking for so that you can, when you get to the work that shows that y is 3, you say, oh yeah, I expected that. I'm not surprised. So now we're going to use one of the other equations. I'm just going to grab that x minus 4y equals negative 10. If y is 3, that's x minus 4 times 3 equals negative 10. X minus 12 equals negative 10, so x equals 2.
Okay.
And now we can go to the last equation, x plus y plus z equals 9. We have 2 plus 3 plus z equals 9, so z equals 4. And we're all done.
Okay.
You could write it as 2, 3, 4 if you wanted.
Got it.
I don't think you're going to get one of those, but what do I know? They just take a while to solve. That's why I said that, because it wouldn't be my choice.
Yeah.
Okay, only about 15 minutes left, so we're probably only halfway through the exam, so maybe reprioritize what you want us to work on.
Yeah, I'm gonna look at chapter 4 now.
Okay, I've got it up.
Can we look at number 3?
Yes. Parabola has a vertex. Okay. There are two equations for a parabola. The first is y equals ax squared plus bx plus c. We do not want this one for this problem. We want the y equals ax minus h squared plus k.
Okay.
Why do I want that? Why do I want that equation? Because it's got the vertex. The vertex is h comma k. So we can immediately write x minus 3 squared minus 5. We still need to find a, and that's where this other point comes in. This other point, sorry, I scrolled past it. This other point is an x comma y. So 3 equals a, 5 minus 3 squared minus 5. I just put those values in. So it's 3 equals a, 2 squared is 4, minus 5. So if you add 5 to both sides, you get 8 equals a times 4. So we find that a is 2. You take that and put it back here to get your final answer. Y equals 2, x minus 3 squared minus 5.
Okay. Got it. All right, these next ones, just a lot of factoring, which is pretty easy. Can we go over 6? It's completing the square.
Sure. 4e is not factorable. It's prime. That's a common thing to mess up.
Oh, yeah.
Okay, number 6, completing the square. There is a formula for this. The formula is based on there being a 1 in front. That's usually the best case scenario here. So the way I do this is I write it as is, but I leave a space here and a space over here, and the same number needs to go in both of those spaces. Well, that number, if this is b is minus 10 in this case, it becomes x minus 5. This number right here is b divided by 2, and the number that goes here is b divided by 2 squared.
Okay.
And if you followed that, then b divided by 2 squared minus 5 squared is 25.
Yeah.
So there's a lot of things going on here. Like the left side, though, this left side becomes x minus 5 squared. The right side becomes 29.
Do we just put 29 on the other side or leave it like that?
So this is where you have to know, and the instructions tell you whether 1, you're solving, which is what we're doing. 2, you're finding the vertex. That's usually the most common thing that they would ask for. So for solving, which is what we're doing here, you're going to use the square root property, which just means to take the square root of both sides.
Oh, yeah. Okay.
So it's x minus 5 equals plus or minus the square root of 29. add 5 to both sides. So x equals 5 plus or minus the square root of 29.
How would you do it by finding the vertex?
You would move the 29 over.
Oh, okay.
So it'd be x minus 5 squared minus 29, and your vertex would be at 5 comma minus 29.
Okay. All right. Next one's simple. Okay, I think I'm good on the rest of that, and we can move on to chapter 5.
Okay, I'm there. We did this pretty recently, so should be
Yeah.
more familiar. Should those dangerous to say. So we'll go over whatever you need to go over here.
Can we do number 3?
Yes. Number 3, given the polynomial, and then we got a bunch of things to do. Okay. Because of the way this is, I'm gonna post the polynomial here as a picture, and then I'll just read off for each question what we're gonna do, and then I'll explain it. So
Okay.
part A says to list all the possible rational roots. So there's a p. The p in this problem is -2, and the q in this problem is 1. This is always the constant, and the q is always the leading coefficient. So the one is right there. That's only part of it though. So you have to write all the factors of p, all factors of p, and you always put them with a plus or minus. So this one doesn't have a lot. It's plus or minus 1, plus or minus 2. And then you write all the factors of q, and you put a plus or minus in front of it. So that in this case it's plus or minus 1. I think I mentioned this, we did this before. It's not a very good example because there's only a few possibilities.
Yeah.
Then you write each factor of p over each factor of q. And you do not have to do the plus or minus. So it's like 1 over 1, 1 over 1, and then 2 over 1. You simplify, and some students don't even write this, and then you write plus or minus 1, plus or minus 2. And these are your possible rational roots.
And that's what you use for the synthetic division.
That's what you use for part B, but you should probably graph it so that you know which one it is. Like I think this happened to be -1 as an example. You wouldn't just want to blindly try them. You'd want to try the one that you know works.
Yeah.
Should we go through B?
No, I got that part.
Okay.
Can we do C though?
We need to do B to do C. So yeah, we can do it. Let me do B real quick. I recall it's -1, so 1, -1, -1, -2. So you bring this down 1, multiply -1, -2, you get a 2, you get a 1. So it wasn't that, darn. Let's see if it's +1. 1, +1, 0. Nope. Maybe it was -2. So let me put a -2 there. -2, 1, -2, that's 3. That's not right. Maybe it's +2. It's +2, 1. Yeah, it was. Okay. So when you use +2, you get it down to x squared plus 0x plus 1, or x squared plus 1. And then since it's x minus 2 times this. So when it says find all other roots, generally what that means is to use the quadratic formula on this, but because it's only got 2 terms, you can actually just use the square root property. If you're not sure what I mean by that, you're setting x squared plus 1 equal to 0. So you're gonna move the 1 over. So it's x squared equals -1. So x equals plus or minus the square root of -1. X equals plus or minus I. So your 3 solutions are 2, comma, positive I, comma, negative I.
Got it. Okay, and then after that, I think just 7.
7, 7, 7, 7. Okay. 7 is a graphing problem.
Yeah.
And I'm just going to use Desmos. And
Yeah.
maybe the most difficult part of this is just finding the zooming in to find them.
Mm-hmm.
Let me get it. Let me get that going here, and then let me new share. Okay, so we got x to the 5th plus x to the 4th minus x cubed minus x squared minus x plus 1. So there's a root there, and there. And look at that, they're already kind of nicely given.
Yeah.
So there's nothing really to do there. I'm gonna write them down, and then I'll snip in the picture.
Okay.
When it says to the nearest thousand, that means just go out 3 decimal places, which you did here. 0.723. Okay, got it. So, yes, all right. Back to the workspace, you'll see that I have snipped in the graph and those answers there. Anything else we can cover that you'd like me to cover?
Last question, 8. Can we just do the binomial theorem again?
Sure. Okay, the process that I do here is different than maybe what you've seen. You have to start by drawing Pascal's. I guess this is Pascal's triangle. I don't remember. Is that right?
Yeah.
I'm supposed to know, but I remember I'm not good at figuring out what things are called. You always start at row 0, which is a little odd. 1, 2, 3, and 4. There's 5 coefficients here, which means there's 4 terms. There's always this plus 1 terms. So there's a coefficient. You take the first thing and the second thing, and you have different powers that they go to. So the first one is 4 and 0, and these always have to add up to that number right there. And we grab the coefficient from over here, so that's 1. And then we start making some changes. So that 4 goes to a 3, that 0 goes to a 1, and then the coefficient you grab from over here, which is 4. And then this goes down to a 2, this goes down to or goes up to a 1. If this was minus y, there'd be a minus y in here.
Yeah.
But since it's plus, it's positive there. We grab another coefficient, and we continue this process here. So this is 4, 3x to the power of 1, y to the power of 3. And then we go down just a little bit more. 1, 3x to the power of 0, y to the power of 4. You're done when the list fills up here. These exponents went down to 0, this went up to 4. And then all you have to do is simplify, which in itself could be a major task. It just depends on your comfort level. So y to the 0 is 1. So this is just 3x to the 4th. 3 to the 4th is 81, x to the 4th. This one here is 4y, 3x cubed, which is 4y times 27x cubed. Excuse me, which is 108 x cubed y. The next one here is 6y squared times 3x squared, which is 6y squared times 9x squared. So that's 54x squared y squared. It's very common to put x first and then the y. Shouldn't really matter, but that's the way. So this is 4 times 3. That's 12x times y cubed. And then this last one, that's 1. That's 1. So this is just y to the 4th. And then you write all of those out together. 81x to the 4th. plus 108 x cubed y plus 54 x squared y squared plus 12 xy cubed plus y to the fourth. And that is it. And we are out of time. So kind of worked out really nicely there.
Perfect.
I will send the notes out to you as a PDF, and the screen recording will upload shortly. Thanks again for scheduling, and hope your exam goes the way you want.
Thank you. I'll see you next semester.
Okay, sounds good. Have a good night. Bye now.